So welcome to this live show here, streaming live with Neonode. And hi, please introduce yourself.
Thank you, Jarvax. My name is Joseph Shane. I'm from Neonode. At Neonode, I was in charge of, or am in charge of intellectual property, and I work on the marketing team as well. So we're happy to share some of our latest products and inventions here with you today. And let's get started.
So this video is looping right here. It's showing some demonstration. You have IR technology. So it's a different way of interacting and touching. It's an alternative to capacitive touch.
That's correct. So Neonode has been quite a pioneer in the field of IR touch. We've developed an IR touchscreen going back actually to our mobile phone, which is in 2004. And then when the company decided to focus on IR touch as a product, which happened in 2009, we've been developing a very advanced, sophisticated IR technology. That technology has been incorporated into over 75 million products, including some of the best known cars, printers, and ebook readers in the world. With today's special situation in the world, we find that IR touch is a wonderful solution when you want to have touch, but not actually contact, not actually have to touch anything. So you can have touch in the air, poking at things rather than touching them. And that is something unique to IR, which capacitive is not able to match the performance and the sophisticated, nice user interface that we're able to. Well, we'll see it here in a couple of demos.
So you're doing something that's even kind of like potentially holographic or floating images, or like when you the idea is potentially if you go in a fast food restaurant, instead of touching the touchscreen where thousands of other people would have touched previously, and it might not be healthy, you could do it like kind of like in the air.
That's exactly right. So basically, the idea behind IR touch is that your finger serves as a reflector of the IR light. And wherever that IR light is projected and your finger reflects it, you'll get the response. So it doesn't have to be glued onto a screen. Anywhere where that light is shining, your finger can perform touch gestures, and we can translate those gestures into as if there was a plane there, as if there's a screen there. So you can do that if you have any way of projecting an image in air, then you can easily poke that in-air image. And if you have an underlying image and you want to touch, let's say, a couple of inches away from the image, we can just detect that as well. So for example, in this video, you see a projection plate. That's a quite nice technology where you can take a display, and with this projection plate, the viewer will see what's on the display as if it's floating in the air. And if we align our IR beams, you see in the video here, with the projection, then you can interact with that projection very easily.
And how do you explain to the user that they don't have to touch the screen? They can just put their finger somewhere in front of it and place the order for the burger or something?
Right. So that's a good point.
Choose the floor they want to go to.
So there again, it depends on. Exactly. So it depends on again how you've implemented the touch. In the case of a holographic screen, where the image appears to the user in the air, it's quite intuitive for the user to touch the in-air buttons. He might not think that it'll work, but when it does work, when he sees a response, either in the in-air buttons or on the physical buttons, he understands that his touch worked. In the case where we want you to point at something but not have to touch it, there's sometimes a little sign that says you don't have to touch the device in order to activate it. So it's more of a, you have to maybe provide some guidance, but it's important to have feedback. So for example, in an elevator, if you've got, in this example where you see the light bar that we have, You see a person interacting, not touching the bar, but because the light responds to the touch, the user quickly understands how he's interacting with the bar. So if you provide some sort of feedback to the user, that should be a quick learning curve.
So how does your IR technology work? And is it your invention to have this IR touch technology? Like maybe it was 10 years ago. I think we did a video, right? Or around 10, maybe it was 8 years ago or something like that, where you were showing the one laptop per child that had an IR on the side, and you were able to add touch to a touchless laptop, basically. Is this kind of like a bar you would use with a laptop potentially, or?
Yeah, so that's interesting. What we have two different types of IR technology that we've developed at Neonode. The one you described with the one laptop per child was a technology that was suited for a frame. So you would have our IR frame surrounding a screen, and the light would cross the frame, invisible to the user. And when he puts his finger on the frame, he blocks the light. We have a second technology, which is what we're seeing here today, and that's a reflective technology. So for this, you've got a single strip of light emitters and light detectors. And when your finger is placed anywhere in a field of light that's projected out of this strip, the reflection is detected by the reflectors. Now, what we've done here is much more than simple proximities, a row of proximity sensors. We have very sophisticated optics that ensure that we can tell exactly where the finger is within this 2D plane projected out of the bar. So with a very crude kind of proximity sensor, you would not get the precision and the quick response that we see here.
So what's the technology you had in a phone? Because when I look at your information, it says that you're in 75 million devices out there. Or where has your
That's true.
technology been deployed so far? Is it in cars, for example?
Yes, so we're in some of the most elegant, sophisticated cars. We have our touch system has been praised highly for its responsiveness and the clear image that the user gets when he sees the screen, because there is no overlay that you have with other technologies. So we're in quite a large number of cars around the world. We're in a very large number of printers. Virtually all the large printer companies have used our technology for the little touch panel that controls the printer. And the ebook reader market has also been very receptive to our technology. Our technology has certain advantages that are clear in these areas. So it's very resistant to electromagnetic interference, which can be an issue in certain applications. If you've got other electronics in the background, and in the case of ebook readers, you have a screen that doesn't have a backlight, so it's very sensitive to overlays. So for these reasons and others, we've been very successful in those areas. But like we said, now that we're going into a sort of a new era where people want to avoid physical contact, then we think that this technology is perfectly poised to provide an excellent solution without having to change user behavior. I mean, we're seeing a lot of attempts to address the issue of not touching the screen with having new apps on your phone, but no one wants to download 50 apps to go to a restaurant and then an elevator and then a hospital and then a doctor. Each one needs its own app. It's going to become cumbersome. We've got voice activation that works in some cases, but it's not always comfortable in a public place to voice activate your interaction with a public device. So if we can keep the traditional touchscreen interface, which people know and enjoy, and just not require the physical touch, I think people will appreciate that a lot.
So what are we looking at here? What is this this demo right here? Is it another holographic kind of demo?
Yeah, this is a holographic demo. So you can't see, we're looking at it from the front. But if you looked at it from the side, you would see that this entire image is invisible. It's in air. It's actually presented on a display that is inclined downwards into this box. And the top of the box has this optical plate. You can see it here. That optical plate is built of very small prismatic mirrors that reflect the light and in a nice way project the entire image that's downward. They rotate it upward by 90 degrees so that it's at a nice incline to the user.
Nice. Is this something that you have in mass production, or is just some demo, and it could be like the future of everything, but it's just small right now, it's just demo?
Well, the good thing about our technology is that it is very mature. So like I said, we've been in business for over 10 years delivering this kind of optical technology. We have a manufacturing plant that's been running for a number of years, creating these sensor modules. So the manufacturing, the process and the technology is very mature. It works well. It's available. You can go to DigiKey and order one today. So there are literally thousands being shipped every week. So it's at a good point technology-wise that this opportunity came up. So it's definitely being adopted, and it's being used in industry and by manufacturers today. And technology, like I say, is mature. We manufacture the sensor. The sensor is what I'm talking about. The projection plate to have that kind of reflective image pop up to the user. That's something that we haven't developed, but that also exists out there. There are a number of companies that have developed very nicely performing projection plates. But as we see in this demo, for example, you don't need the projection plate to enjoy the benefits of not touching the screen. Even if you have the screen, a real screen, and you simply lift the detection plane from the screen, you allow the user a very nice interaction with the screen without touching.
So this is without touching, this demo. I mean, touching optional, basically. The capacitive sensor could still be there. You just add an extra sensor that's hovering on top, kind of.
Well, it's not capacitive. This is an IR touch plane. So the IR beams that you're seeing here are above the screen. They're removed from the screen a couple of millimeters, but it's completely configurable. As you can see, that little shelf on the top determines how far the detection plane is separate from the screen. So it makes it very easy for the device manufacturer to give the user the right field that he wants. For example, if we compare this to a capacitive screen, some capacitive screens have the ability to detect even a hovering finger above the screen, but that detection must be quite close to the screen. And as it moves away from the screen, the detection deteriorates significantly. So if the user was going to use a capacitive technology for this, I believe it would be more difficult to have a comfortable use, because either the user would be too close to the screen or they wouldn't be detected.
And let's say you have a capacitive at the airport or at the fast food restaurant, you would need to disinfect it after every customer, and that kind of, I'm imagining, could maybe destroy the screen or something like that. And so it would be, I mean, what I'm saying is that potentially you could still have the capacitive, like maybe are deployed in millions of devices. Just add yours as like an optional thing on top that converts it into both contactless and contact.
Sure,
if people don't know that it's contactless.
Our technology doesn't interfere with whatever is going on the screen. If the screen has a built-in capacitive touch screen, you can still provide touch input from another device. And that's exactly what our sensor does. It provides standard input to the device as if a touch screen is detecting these touches. So it can be a USB HID interface or any other standard interface. We support all of them in our library. So it's very easy to retrofit any screen, whether it had touch or didn't. You can use our technology to remove the touch from the contact.
And your infrared is invisible, right?
Yes.
It's just magic.
There's no magic. It's science, but it works. Maybe our eyes are not sensitive enough to see the light. So it's in a spectrum that we don't see.
And this bar that you have up there, you could potentially have all kinds of different sizes for different sizes of displays.
Sure. If you go to DigiKey today, I mean, you can see the different sizes that we provide that are all standard, parts with part numbers. And obviously, this technology is expandable and customizable. So if there are particular needs for particular sizes that we don't, that are not part of our standard offering, then of course that can be provided. But we think that the sizes that we provide about 10 different sizes. And those are pretty standard to cover a lot of use cases.
And what's the parallel plane touch that
What we are seeing,
you
though,
also
is
talk about?
Yeah, so parallel plane is this idea that I was talking about, where we have this touch plane. Anything that the light that comes out of the bar provides the touch plane, and that plane can be placed anywhere. So if you place it right up next to the screen, then that screen will become a touch screen. And if you remove it from the screen, then the touch will be separate from the screen. So we call that the parallel plane configuration, because you've got the touch screen in the background or some surface in the background and another plane of touch parallel to that surface.
Is that what happens there? Like potentially it could be next to the laptop on the table or something like
that? Sure, it doesn't have to be at the laptop at all. But let me give you an example in an elevator. So if today you have an elevator with an elevator button panel, and those buttons are not digital, they're not a touch screen, it's just regular push buttons, and you don't want to touch the buttons, you could provide one of our sensors sticking out from this panel and projecting a light sheet down above the panel, and then all you have to do is point at one of the buttons to activate it.
Nice. Maybe we can go to that website. What do you call it? The website where you have all your parts available? People can order them on...
I think that's, digikey.com.
DigiKey, yeah.
I think the Neonode website itself has a product site where you can also see the different sizes.
So maybe we can also bring in some questions from the chat. Let's do...
sure.
How about this? Does the contact go both ways?
Go both ways, Sir Patrick Reynolds.
Yeah.
Can nano go into someone using these? I don't understand the question so well.
Yeah, I'm not totally sure neither. How about haptic feedback? There's a question about haptic feedback. That would be another technology that would potentially do contactless haptics, right?
Right. So haptics is an exciting field, and especially when you come to contactless, it feels like magic because there's nothing there, and we could easily, use a haptic engine to provide haptic feedback. Right now, in the implementations we're seeing, Neonode doesn't provide haptic feedback, and we're looking more at having some sort of visual response. So when let's say if you had this elevator button panel and you point it at one of the buttons, if the button lights up, that would be your feedback. That would indicate to you that your selection has been registered. But of course, if there are haptic feedback, systems that you can use, and they can coexist with our sensor. Our sensor is simply the detector of the touch.
And
so it would be
I'm going here.
Of the haptics.
I'm going here on a YouTube video, very old video, because you had a famous device 13 years ago that already had the Neonode technology in a smartphone. Pretty much, it was like very early smartphone, right? What is this device?
Yes.
With a full card SD card slot.
A very early prototype. Yes, the old SD card. This is called the N1 or the N1M Neonode phone. and it was introduced in 2004, and it had this revolutionary idea at the time to have all of your input, all your gestures, all your interaction with the phone will be buttonless. It will be all on the touch screen. So here you can see that touch screen. The user is probably going to unlock the phone. Let's see what he does. There we go.
This is this is 6 years before the iPhone, right?
2004 is 3 years before the iPhone.
3 years, yeah.
Yeah. So this was a nice idea. I mean, it came out in 2004. Obviously, there was a lot of production and technology development that went into the phone. But the phone was released in 2004. The idea was proof of concept to actually put it out on the market and see what the response was, how it worked. So there's a very large number of innovation and work that went into this phone. Yeah, Neonode had hoped that this would really take off. But at the time, touchscreen technology was in its infancy, and the technologies that existed were not compatible with the type of use that the Neonode expected from a phone user. So therefore, one of the innovations that they put into this phone was to develop an IR touchscreen for the phone, and that later grew into our current business.
And I'm trying to load our old video. We met in, I think it was Mobile World Congress 2012. And I think you were talking a lot about the auto business. So how's it been going with your automotive business?
The automotive business has been around for a while. We've been in the business for over 5-6 years now with several customers. It hasn't captured the market the way we had hoped. There are other technologies that have more market share than ours, but we have some loyal customers, certain lines of cars that insist on using our technology, and we're very proud of that.
So here I'm trying to load some of the content from that video. People can check it on my YouTube channel. You're talking about the phone.
You can see this is the second generation of the Neonode phone. Yeah, so that's the second generation phone. That was more of a real product that we wanted to launch. You can see it has a very nice design, very compact, very elegant, curved edges. And
what is this big touch device there?
Yeah, that was more of a demo for proximity sensing and pressure sensing, which was something features that we were providing for then.
All right, but so you are based around near Stockholm, is that right?
Yes, the company is headquartered in Stockholm. We have a really nice office there, and we have a number of smaller offices around the world that are focused on providing close contact to our customers. We have an office in Japan, an office in Taiwan, an office in California.
So this was 2013 also when I did the video with your colleague showing the automotive more focused business, right?
Well, actually in automotive we have two tracks. So we've got, or 3 tracks actually. We have the track which is the touch screen in the center stack of the car, and that's like we said, it's in thousands of automobiles today are using this with a lot of success. We developed in addition some sort of interactive steering wheel with a very sophisticated type of user interface on the steering wheel. And we've also developed a driver monitor or cabin monitoring system based on very sophisticated AI software. So that's a software product, not a optical sensor, but we do the software analysis of the cabin to monitor activity and shot behind, driver awareness, driver alertness, things like that. So there are three different segments in the automotive, and I'd say right now the strongest are the entertainment system, where we have the touch on the screen, and the driver and cabin monitoring system.
And I'm just checking around a little bit on YouTube. Some other demos that were recently shown. This is showing more of also the holographic kind of interface.
Right. So this again, I mean, this was showing the holographic interface before there was a recognized need for holographic interfaces. So at the time, it was more of a novelty, but I'd say in the last year, this has really been, shot up to the forefront as something extremely compelling and useful. And there's been a lot of interest.
So there's one comment that says you're limited only by software. So if people have great ideas, it can be very exciting what they could do with your technology.
Exactly. So the technology is extremely versatile. Basically, you see here that little bar, that is the sensor. So it's a sensor that gives you the opportunity to detect touch, gestures, swipes, anything like that. And with that input, the sky's the limit. The developer can do anything. If they want to detect these swipes in air, that's a whole area of development. If they want to detect these swipes on a stone or on a piece of leather or on a piece of cloth, those are other areas to develop, and they're all equally supported. The user has a very extensive and easy to use library that our product comes with, and it can download from our website. And with that, you can develop your own product. What is the typical circuit interface? Randall asks. So we have again, we support all the standard interfaces. So USB HID, I2C, drawing a blank of what the others are, but all standard interfaces are supported.
All right. This is more holographic demo, like what could be in a restaurant, for example, with no holographic contactless, ordering the food.
Right. So I think restaurants are a very big area where there's going to be a lot of demand for, for automation and.
Yeah, can I hear you? I don't hear you right now. Okay, there, okay, there you are. There you're back. Yeah.
Sorry, somebody called in the middle of this.
Yeah, so yeah, the restaurant is a big potential business. And if I scroll down, this is your official YouTube channel. Maybe there's some other videos you might have shown here. I'm just going to try to, let's open touch module demo. Are you back with your sound? No, I need to bring you back right here in a second. Z-Force Air. If anybody else has some questions, Joseph is reconnecting, I'm pretty sure.
Yes, I'm reconnected now, I think.
Coming back.
Yeah.
Looks like loading. How about now? Yeah, it's good. Yeah, I hear you.
Okay, good.
What is this touch on any surface? This kit?
Right. So as we said, this sensor that we provide basically gives you a 2D plane in which to detect touches. And wherever you direct that plane, that's where the touch will be detected. If you direct the plane on top of a piece of fabric, then that fabric becomes touch sensitive. If it's in the air, it's the air. And if it's on a stone or a piece of leather, then that's what becomes touch sensitive. So you really have a lot more design freedom if you wanted to use exotic materials, if you wanted to use wood, for example, in a device and have the touch on the wood, that would be a perfect use case for our technology. Do you have to use your finger? So again, that's a good point. Patrick asks. What we rely on is reflectance of the IR beams. So anything that will reflect the beams can be used, whether it's a finger, a pen, a stylus, or anything else. It doesn't have to be a finger.
Has to be the size of a finger?
Size as a finger works. Okay, we've got that. No, it doesn't. anything that will provide the reflection can be detected. However, in addition to detecting the object, we detect a lot of features of the object. So we can, for example, distinguish between different size objects. We might want to only react to a finger and not to a fist, or something like that. So we can detect everything about the object in addition to the touch. We do the size as well. We do the force. We do the
And
speed.
And is it true that your technology is in increasing demand in these strange times of new requirements everywhere and everybody being careful with where they touch and everything?
Sure, we're getting a lot of interest in many different industries, and I mean this has become a key issue in a lot of areas. People want to address this issue. A lot of companies and services want to address customer concerns and user concerns. So this has definitely become a hot topic. And fortunately, our technology is ready. It's not something that we had to develop at the last minute to solve this issue. It was out there, and by simply adapting it to the current situation, it's really provided a wonderful solution that people can use today.
How about the price? Is it affordable to use your technology in devices, or is it more like a premium special kind of thing that's more enterprise, or how would you describe the price, kind of?
I would describe it as a very competitively priced technology. It is not it's a premium technology because there's so much, so much work and technological development that's gone into this. I mean, the optics are extremely sophisticated, but the manufacturing process has been, cost down, and you can see the prices on DigiKey. That's for individual products. So we're talking in the range of $10 to $20, or $10 to $70, depending on the size. But it's a very competitively priced, and certainly compared to other touchless technologies, I think it's very well positioned.
Are you on some famous e-reader devices out there, like big brands, right? Maybe I don't know if I can mention them, but
customer.
yeah,
We don't discuss our customers unless they want to discuss them, but we don't discuss particular customers.
I'm guessing some of them might do capacitive, but actually your technology is perfect for e-ink because you don't add anything on top, or there's no risk of interfering with the readability. So it's been great, I'm sure, for millions of people, right?
Yeah, we've had a lot of success in the e-ink market. That's true.
So what's the biggest markets that are coming up?
Well, we'll have to see. I mean, right now we are addressing 3 main markets, but I think the one that's getting the biggest buzz certainly is the new situation that requires or that prefers contactless interface. So that's going to be a big area with a lot of development, a lot of smaller companies doing retrofitting to existing products. So that's extremely exciting. And it's going to be a challenge to support all of the demand that's coming in from all these different channels. We have 2 other areas that we focus on. One of them is a very high-end optical touch that's built into the screen. And that has application for high-end areas such as aviation, industrial applications, and the third, or medical applications. And the third area is, like I mentioned before, driver monitoring and cabin monitoring, where we're also, if you think about our technology for a moment, this sensor can conceptually be looked at as an extremely primitive camera. Basically, we've got individual light beams. We detect each beam as being blocked and the position of the finger with relation to each beam, but it's really a very crude camera. And yet with this camera, we have invested many years into algorithm development to extract data from this very primitive data set. And using this knowledge of how to extract a lot of data from a very small amount of data, small amount of information, we are able to. So that was our motivation to enter this idea, this new area of cabin monitoring, where we can have a camera, and even if it's a low cost camera and a simple camera, we can still, with our algorithms, extract a lot of useful information about what's going on in the cabin. So those are our three business areas.
Actually, 2, 3, 4 years ago, you were talking about flexible, kind of like smartphone display kind of thing. And how does your technology fit into this kind of curved or flexible displays?
So it's kind of interesting. This is a novel property of light. Light is reflects, and light will bounce off of things. And therefore, if we have, so the light, in this case, if you if you bend the screen, the light actually follows along the contour of the screen. And any place you touch, you can, so even if you touched not only on the flat part of the screen, but even at the curved part of the screen, your reflection would go back around the curve and back to the sensor. So in that way, we're able to detect touch even on a flexible screen.
Are you shipping anything that's flexible, like something that looks like that?
So like I said, Neonode's product is not a display. Neonode's product is only the sensor. And if a device manufacturer or display manufacturer contacts us and says, we want 100,000 sensors, and then we shipped it to them and they put it into their device or match it with their display. So if there's a flexible display manufacturer that wants to use our sensor, it's a very simple integration, but we don't manufacture displays.
And then you had an air bar for sale, right? Some products you've been selling, like consumer products, right?
Right. So that was, I would classify the air bar as more of a proof of concept. So we had this idea for this reflective technology, and the best way to, improve it and bring it to a mature state is to release it to the public, which is what we did, and we created this air bar product, which the idea of it is that you can place it at the base of your screen of any laptop, and then the light beams will be projected along the screen and provide touch to the screen. Of course, you can see as in this video that it doesn't have to be on the screen, it can be anywhere. Next to the screen, it'll also be interpreted as if there's a touch on the screen. But the air bar was a device that was, I'd say, part of Neonode's final stretches of development. And right now, we're focused on using this mature technology and addressing B2B customers.
Then let's bring in this question right here. What's about contracts?
Okay, so Leonard
well,
asks,
maybe
what is to be said about the communicated? Yeah. I lost it.
Oh, you lost it?
Here, what is to be said about the communicated contracts these days? Okay, so Leonard, I think, is addressing, Neonode has made a couple of number of press releases regarding customer engagements. But unfortunately for this, in this forum, we are not discussing actual Neonode customers. Those have to be dealt with carefully, and I leave that to management. This is more a discussion of the technology and where it's going.
I'm wondering, do you have like competitors doing IR kind of touch stuff, or you invented it and you dominate this market?
We did develop it very early, and I would say we were one of the first to provide IR touch as an alternative to capacitive or resistive touch screens. So we've definitely been out there early, and our technology is very mature. Recently, I have seen a number of other competitors sort of entering this field by providing an IR touch frame. But we think our technology is far superior because we have developed it to the point where we're a reflective technology today. that requires a bar or a strip along only one edge of the screen, as opposed to an entire frame. And like I said, the software is mature, so it's got a good ecosystem around it. And the idea of a single bar being a reflective sensor for any surface or for touchless contact, I haven't seen anyone provide that other than us.
So for 15 years, I've been dreaming about this device.
Android.
That would be like a pocket device, you know, with a Pico projector inside, and you would prop it up on a table, and it would make a 20-inch display on your table, and then there would need to be an IR interface for this kind of stuff. Let's say somebody wants to develop something like that. How do they contact you, and how do they make it real? And you really need to have a bar along the whole width of the touch area, or can you make it go out, kind of? You know what I mean?
Those are interesting ideas. Right now, our products that you buy off the shelf at DigiKey support a rectangular area. So the dimensions of the touch are determined by the length of the bar, and pretty much it's going straight up. So we don't have a funnel-shaped detection area today. But it's definitely an interesting idea. So if someone wanted to make that sort of product, they would have their little Pico display projector, and then they, depending on how large they expect the projected image to be, they would take a sensor that is as long as that projected image and place it at the base of the image, and then interact with the image.
And so would you work with manufacturers of large industrial touch displays, maybe in Asia? Is that kind of the business that you have, where you work with them and you integrate your tech into their products, for example?
Yeah, like I said, we have 3 different business areas, and the first, where we incorporate this high-end touch into the display, or with the manufacturer into their display, that's aimed at high-end products like aviation and industrial applications, medical applications, and there we have specific partners that we work with to help them incorporate our technology into their products.
Is it kind of what's called is there like some risk that there's interference with that IR that gets blasted around, or it just stays right there and what the display is? It's not going to interfere with your smartphone signal?
No, the IR light doesn't interfere with the smartphone signal. One of the big advantages that our technology has is that there is no risk of electromagnetic interference that, let's say, other technologies might have more of an issue with. If they're detecting, a current, then other currents in the area might interfere with that signal. But we're detecting
actually
the blockage or
capacitive
reflection of
touch.
light.
Capacitive touch might have interference.
Right.
Here it says, oh, no, sorry. No, I'm not going to. This one, some patents. But you have, I guess, partnerships with all kinds of companies. You might not really mention exactly who they are and stuff like that. Yeah, also about companies. I mean, there's big companies that probably are very excited to use this technology, right? We already said that you can't mention exactly who it might be.
Yeah, we don't discuss particular companies. There was a question also that was raised regarding Neonode's patents. We had developed some patents early. Those patents did not belong to Neonode any longer, so we don't discuss those patents publicly any longer. They are they belong to another company now, and that's their business.
All right. Cool. So the special situation, and when you talk about into the displays, you're basically talking about putting them in the bezels, right? It's not something else that I'm not understanding that goes somewhere else in the display.
When you're talking about our first business area of incorporating the touch into the display with the device manufacturer for high-end applications like aviation. Yeah, in that
so that's
case, it
bezel
goes into
stuff.
the bezel, but it's built in. Yeah, there is a bezel. The bezel should be minimal. but it's part of a design that we work with them to make an optimal mechanical design, optical design, electrical design. All of that has to be brought into account with the other components in their display today. So there's some close interaction, but we think that our software is built in a very modular way that allows the user to interface very easily with the software blocks that we provide.
All right. And so if there is some mass production that happens, and when, if let's say millions of devices go out and influence all these different restaurants and everything, all this can happen very fast in partnerships, or if people want to develop new stuff, they just go on DigiKey and they started developing new stuff and they talk with you about making big quantities.
That's right. So DigiKey is the place to go to start out. Anyone can go there. Small, big companies that can order, a large number of sensors and get their product development underway. And then we deal with very large orders that need to be dealt with on a different level.
Nice. And how's it going in the company in this strange time? Do you have everybody working at home, or everything's fine now over there in
these
Sweden?
Are strange times indeed. Yeah, so Sweden, like the rest of the world, is deeply affected. So we fought the Swedish government, and the Swedish health ministry has a very transparent communication with the public here. So we follow their guidelines.
How big can it get?
The guidelines today
like somebody's asking how
most of the work can be done from home, and some is interactive. Yeah.
So how big can the sensor be? There's no limit? Like I have a 120-inch this projection display here. What's the limit?
Technically, light can travel even 120 inches, yeah. But with that, those are not the things. I mean, our sensors today are not built for 120-inch displays. Technically, we could, maybe put a couple of sensors together in a row, and then in that way support larger display sizes. But that's under development.
Because I went to the Qatar museum. They have a national museum that has these huge projectors and all these impressive things. I can imagine like the museum market or because they like to have the cutting edge holographic kind of UIs, and maybe that's also a place to demonstrate the future of tech with partnerships with some of these kinds of places, maybe. They want big,
Could
maybe.
These are all, these are all options, and it's like I said, it's a developing market. This holographic touch and touchless interaction, and you have to find the right technology for each use case. I mean, ours is really focused on I'd say accessible to the consumer kind of applications. If it's an ATM machine, if it's an elevator, I think these amusement park level interactions might be they might have a different target user interface experience. They might want more of an interaction. They might want to see if you're jumping or dancing in the street, and you might use other technologies for that. But certainly, if there is an opportunity to use ours as well.
Maybe the government should just say Neonode is compulsory for every ATM machine. Because in the last few months, last 9 months especially, I'm always using I'm using my sleeve when I touch on all these buttons out there. Like it comes up in not only because of the situation we have right now, but in general, there's always people who have the flu and stuff like that. It's not really nice to touch public things, So it needs to become like mandatory, this stuff.
I don't know. I mean, these are different times, and I'm sure that over time we'll come back to a more calm, way of living. And but things will probably be adapted in a way that we feel that people understand are safe to interact with. So we won't have to have this on our minds all the time.
I think it's a positive thing if we can get out of this strange situation that people are maybe going to learn to wash their hands more often and also not touch everything and try to think about that a little bit more, because it's not only this thing, it's a whole bunch of things that it's not very good if people get very sick with different kinds of stuff. Okay, but yeah, that's.
Yeah, but I mean, people have been living for a long time and we haven't been susceptible to big disease outbreaks because of I mean, obviously in the right setting you need to ensure that people are washing their hands, but to make it a national priority, we'll have to see if that's what happens.
And here's a question from Matthias Torgren. But it's also a little bit what we were talking about, I guess.
Okay, so let me read the question. Do you push and work together with target industry in any way to develop your systems in certain directions? For example, if you've got a neat idea of a usage that is currently not in the marketplace. For sure. I mean, we get approached all the time with very creative ideas. And we have to evaluate. We have a limited amount of resources that we can allocate to new development ideas. But sometimes it's a very promising direction with a very promising customer that is behind this effort, and we certainly will we put a lot of focus on those areas.
Cool. All right, but thanks a lot. I'm looking forward to see what comes out of all this, because it'd be nice to see mass production of crazy holographic stuff and new ways of interacting with technology, and maybe more user-friendly, easier for the elderly to use, maybe easier for the small children to use, and healthier and without having to wear gloves and all that stuff.
I don't know, but I'm hopeful that these new kinds of interfaces will become just second nature and almost taken for granted in a very short amount of time. And it'll be like a smartphone. 20 years ago it was incredible, and now it's kind of short. So hopefully these interfaces will reach that level of penetration.
It's what made the success of the iPhone and eventually the iPad, is because they made some contracts with the people who had capacitive technology, and they went and they said, we want your capacitive technology on our little device, and boom, that was a big success. So maybe the next step is something that's a new, even different kind of way to interact with this technology. And so maybe you're the next,
Yeah, I mean, Apple
iPhone.
really had a great idea to make things simple and intuitive. I think that's the key. And if you have an intuitive, simple interaction that works, then I think there's a good likelihood that it'll be adopted. So let's see.
Cool. Thanks a lot for your time. Thanks for this interview. And I hope everything is smooth and the video is smooth, hopefully, and people can watch it on YouTube. They can watch it forever.
I hope so.
Cool. Thanks a lot. Okay.
Thanks a lot.
Thanks for your time.
Bye-bye.
Thanks. Bye. All right.
Bye.
Clicking right here to end the broadcast.